Hello, good afternoon. My name is Arda Yaldız. In this video, I will be answering the questions that are asked in the experimental procedure video of experiment 3. In the first question, it is asked that for the open loop test, what is the reason behind us observing different values for the current ratings at each phase? The answer for this question is we have different RC and XM values for each of the phases. This is the circuit representation for the open loop test on a single phase. And since our RC and XM values are different for each phase, this makes our system unbalanced while we are performing our open loop test. And because of this, we observe slightly different current rating values at each of the phases. For the second question, it is asked why we connected our wattmeter such that all the phases enter the wattmeter, but only two of the phases are connected to the load, while the third phase is directly connected to the load, bypassing the wattmeter. The answer for this question is that in the experiment, we are using the 2 wattmeter power measurement configuration that is visible on this figure. This black box here is our 3-phase transformer. The secondary side of our transformer is connected to the second wattmeter, and the primary side of our transformer is connected to the first wattmeter, and this is our load. In this configuration, only 2 of the line-to-line voltages and 2 of the phase currents are enough to measure the power dissipated on the load. In the third question, it is asked why we didn't connect the neutral lines of the load and the secondary side of the transformer. Both the secondary side of our transformer and the load are connected in Y, and these are the neutral points of both of them, and we haven't connected them in our experiment. The answer is that since we have a balanced system, which means that the voltage of the neutrals at both load side and the secondary side of the transformer are equal to each other. So it's not necessary to connect the neutrals to each other, since they have the same voltage values. For the fourth question, it is asked why we have a fan behind the resistive load, but don't have one for the inductive and the capacitive loads. The reason for this is since there is not any real power dissipated on the capacitive and the inductive loads, we do not have I squared R losses, which cause a heat output from the system. But for the resistive load, there is a real power dissipation on it, and there is a heat output, so we have to cool it down. Our final question is the reason behind the increase in power when we connect one more inductive load, which makes the system go from 2R2L to 2R3L connection. The answer is that in this experiment, we are connecting our loads in parallel to each other. These are the single phase representations of our loads, but usually they are Y connected. Since we add another inductive load in parallel to the other ones, the total reactance of the system decreases. This results in an increase of the power factor of our system, and because our power factor is increased, we start to supply more power from the input side of the transformer. These conclude my answers for the questions in the experiment video. Thank you for listen.